Hello, Applied Physics students. Here is your teaching video for the Concept Development Practice page 29.1, and we'll see that this is about reflection, and we're going to be using the law of reflection. Remember, the law of reflection states that the angle of incidence and the angle of reflection are equal to each other. The incident ray, the normal, and the reflected ray all lie in the same plane. The law of reflection applies to both partially reflected and totally reflected waves. Remember, the angle of incidence is the angle, or the incident ray is the incoming ray, and then the reflected ray is the ray that is coming off of the surface. So, number 1 here says, light from a flashlight shines on a mirror and illuminates one of the cards. Draw the reflected beam to indicate or show the illuminated card. So we want to figure out which card here is going to be illuminated. So to do that, again, we need to kind of probably use a ruler, and we need to reflect these rays. And again, kind of whatever this angle is that it comes in at, it's going to leave at about the same angle. So I'm going to kind of try to approximate that. Okay. So kind of maybe looks like this. Right, so there's that one. Here's this middle one. And here's this last one. So we see that the only card that's going to be illuminated here is card B. And again, that's because this incident ray, this angle here, should be the same as the angle of that reflected ray. That's what the law of reflection says. Number 2, a periscope has a pair of mirrors in it. Draw the light path from the object O to the eye of the observer, right? So again, the light from this little bee or butterfly comes into the periscope and it hits this mirror. When it hits this mirror again, it's going to be reflected to the next mirror. And again, the law of reflection says this angle and this angle have to be about the same, or should be the same. So I'm kind of trying to approximate that. Then this light is going to come in and hit this next mirror and be reflected again. Okay, into the person's eye. And again, the law of reflection says this angle and that angle should be the same. Okay, so that is how that ray moves. The ray diagram below shows the extension of one of the reflected rays from the plane mirror. Complete the diagram by, number 1, carefully drawing the 3 other reflected rays. So again, this angle here is the same as this angle here. So this angle here, I need to make my reflected one have about the same angle. Okay. So it's a pretty small one there, right? Maybe that's about the same. So there's my angle coming back. Okay. Here again, this angle, the law of reflection says that angle and the angle of mine that is reflected need to be the same. So maybe about right, okay, maybe about right here. And then again, this last one, this is a pretty big angle really. So I'm going to have a pretty big angle, okay, right here. So there are my reflected, okay, rays. Now, extend them to behind the mirror. So now I'm going to kind of go back to these that I drew, and I'm going to extend them. Okay, so this is what I have, and kind of where they all meet, which is kind of right in this vicinity here, right? This is where I would see that flame of that candle in my reflection. Because this is a flat mirror, right? A plane mirror, the distance here should be the same as the distance here. Okay, remember that was the thing, and it should be the same size, so I didn't do a great job with that, but my flame would also be the same size. So number 4, the ray diagram below shows the reflection of one of the rays that strikes the parabolic mirror. Notice that the law of reflection is obeyed and the angle of incidence from the normal, the dashed line, equals the angle of reflection from the normal. So what it's saying here is this angle here and this angle here are the same. Complete the diagram by drawing the reflected rays of the other 3 rays that are shown. So again, idea here is, here's my normal, here's my angle. I need about the same angle, which that's a fairly small one. Okay. Maybe about right there or so. Okay. Coming back. Okay. This one again, here's my angle. So I need about the same size angle. So again, maybe about like that. And then here, right, this is a pretty big angle. And there's about that same angle. Do you see why parabolic mirrors are used with automobile, right? This is our concave mirror because we form a cave, okay? And again, what they're saying here is, do you see why parabolic mirrors are used for automobile headlights? Because notice, it's taking all of the light beams, okay, right? Naturally, this light is giving off light in this direction and in this direction, but it's also giving off light in the backwards direction. Where is all that light being directed? Forward. So basically, by these mirrors being used this way, all of the light is directed forward in the direction the car is moving, which is what we want. If it wasn't that way, our automobile headlights wouldn't be nearly as bright as what they are. Number 5, a girl takes a photograph of the bridge as shown. Which of the 2 sketches correctly shows the reflected view of the bridge? Defend your answer. Okay, so the question is, right, we know that we have some light hitting in front of this bridge. What would the view be, right, from down here? So again, the reflected image is actually going to be this one here. Okay, so the right view is the correct one. The reflected view shows the underside of the bridge, or what you would see if your eye were as far below the water surface as your eye is above it, right? So what we're saying here is this distance here, well, you would also be able to see the bridge as if your eye were at equal distance right here, okay, and seeing. So you would see the underside of that bridge. So this is what you would see in your picture. So that's a little bit about the law of reflection. Have a great day, and I'll talk to you tomorrow.